Hello students, in previous videos we have discussed about synchronous generator construction, types of rotors and winding terminology, winding factors and differences between AC and DC generators. In this video especially we will learn about EMF equation of synchronous generator. So what is the EMF equation of synchronous generator? So this EMF equation is very important for your examinations, even for your computer examinations also, for like GATE exam, HAL, ISRO, DRDO and state government like KPTCL, KPSC exams also. This EMF equation is very important. Minimum 2 marks or 3 marks questions will be asked from the EMF equation, right? So coming to the EMF equation, before going to derive EMF equation, we should assume the sum of the notations like P, number of poles. P means number of poles. Already we have seen in DC generators, right? Model number 4. And N, speed of rotor in RPM. Z, number of conductors in series per phase. Number of conductors are connected in per phase. TPH, number of turns per phase, that is equal to ZPH by 2. If you want to frame one turn, so we need 2 conductors. That's what TPH is. TPH is half of the TPH value will be half of the ZPH value. That's what TPH is. You can write it as a ZPH by 2, right? And F, frequency of the induced EMF in Hertz. Pi, flux per pole in Webers, considered to be sinusoidally distributed. KD, distribution factor. So distribution factor is equal to sin q alpha by 2 by q sin alpha by 2. Kp, pitch factor or coil span factor. So Kp is equal to cos beta by 2. Kf, form factor. So form factor is 1.11. So form factor is the RMS value by average value. So if you take that will be equal to 1.11, right? So coming to the derivation, first total flux cut by one conductor in one revolution. The total flux cut by one conductor in one revolution will be equal to P into pi. So since generator will have P number of poles, so the total flux cut by one conductor in one revolution is equal to P pi Webers. Time for one full rotation equal to 60 by n seconds. One revolution, one complete revolution, so that will be equal to 60 by n seconds, right? And rate of change of flux by one conductor according to Faraday's laws, so we can write as d pi by dt. Faraday's first law, Faraday's second law we have. So Faraday's first law says that whenever conductor cut the magnetic flux, EMF will be induced. Whenever conductor cut the magnetic flux, EMF will be induced. That is called Faraday's first law. Second law, the rate of change of flux is equal to induced EMF. According to that, rate of change of flux by one conductor is equal to d pi by dt is equal to pi p by 60 by n. Pi p by 60 by n. So as we know that the induced EMF is due to rate of change of flux by coil. The average induced EMF in Z conductors per phase is E average is equal to pi Z P n divided by 60. Pi Z P n divided by 60 you will get. So after substituting, so you will get these things. So where F is equal to frequency, Pn by 120. Pn by 120 you will get. So from this above relations, so average EMF induced EMF, average induced EMF is equal to 2FZ pi volts. So after substituting, simplifying, you will get that one, right? So Z is number of conductors convert into turns per phase here. So 2F, so here 2F into 2 into TPH pi p. So here we are converting Z into number of turns per phase TPH. Okay. So finally what we will get, E average is equal to 4F by TPH volts. So form factor, according to form factor, RMS value by average value. Definition of form factor is the ratio of RMS value to average value is called form factor, that is equal to 1.11 we will get. Now RMS value of induced EMF, RMS value of induced EMF is equal to 1.11 E average. E RMS is equal to 4.44 F by TPH volts per phase. E RMS is equal to 4.44 F by TPH volts per phase. So substituting values. So but the induced EMF in synchronous generator is depends on the factors, pitch factor and distribution factor. So finally the induced EMF will be taken into those two factors. So EPH is equal to 4.44 F by TPH Kp Kd. So it is measured in terms of volts. So finally what is the EMF equation of synchronous generator? 4.44 F by TPH Kp Kd. So where F is equal to supply frequency, pi is flux per pole, TPH is equal to number of turns per phase, that is equal to ZPH by 2 we can write. Kp is pitch factor, the formula of Kp is cos beta by 2. Kd is distribution factor, sin q alpha by 2 by q into sin alpha by 2. So these are the factors. So induced EMF will be depends. That's what. So finally EMF equation of synchronous generator EPH is equal to 4.44 F by TPH Kp Kd. Suppose the alternate is star connected. If the armature windings are connected in star, the line EMF in synchronous generator, the line EMF here, the line EMF EL is equal to root 3 into EPH. This is a relation already we have discussed in second module, 3-phase circuits. So in that we have discussed star connection, delta connection relations, right? So in star connection currents will be same, line current, phase currents will be same, but line voltage and phase voltage will not be same. So there we have calculated one derivation between line voltage and phase voltage. There we got line voltage is equal to root 3 into phase voltage. So according to that, line voltage will be equal to root 3 times the phase voltage. The armature windings are connected in delta. Suppose the delta connected armature, the line voltage is equal to phase voltage. The line voltage is equal to phase voltage. So this is about EMF equation of alternator. So this is one of very important question for your examinations and also for competitive examinations. If you are write any state or central government exams, so minimum 1 mark or 2 marks, so minimum 2 or 3 marks, so will be asked from this EMF equation. Even for GATE examinations also they will be asked from this EMF equation concept. Okay, so this is about EMF equation, and next video we will see problems based on synchronous speed and EMF equation. So problems also important. In next video we will see. Okay, thank you everyone.